Good morning, students. Today we see another topic called stacks. A stack is a linear data structure in which new data items are inserted into and existing items are deleted from only one end. But before going to the brief description of the stacks, we have to learn what is a linear data structure. Actually, the data structure is broadly categorized into two types as linear data structures and non-linear data structures. A linear data structure is a data structure in which the data items are stored or represented in sequential order, that is contiguous memory locations. We can exactly extract one data item after every data item in the case of a sequential or linear data structure. The examples for the linear data structure are arrays, stacks, queues, and linked lists. Whereas a non-linear data structure is a data structure in which the data items are stored in non-linear fashion. That means every data item is stored or connected to two or more number of data items directly beneath it or in different directions. Here the data structure is represented using the pointer notation. Then we can again come back to the stack concept. A stack is a linear data structure in which new data items are inserted into and existing items are deleted from only one end, called the top of the only one end. The end at which the both insertion and deletion take place is known as top of the stack. So top is an index variable that we use to manage the operations on a stack. The insert operation on the stack variable or the stack operations is called the push operation, pushing an element, and the delete operation on the stack is called the pop an item. In a stack, the data item that is pushed last is the first item to pop out. So thus this data structure follows the organization of data items in LIFO order, that is last in first out or first in last out. The data items that get into the stack last is the first data item that we can delete first. Next, the representation of stacks. A stack can be represented in two ways, as the static representation and dynamic representation. The static representation of a stack uses array implementation. Here the size of the array is fixed before the stack is put to use, whereas the dynamic representation of a stack is performed with the implementation of pointers and runtime memory allocation. That means the dynamic memory allocation functions are used to create every data location and then attach that location to the previously created data items. A general example for the stack is a stack of plates in the idli cooker. Every day we might have seen the idli cooker in our kitchens, where there will be an aluminum container in which a stand is placed that contain a number of plates like this. Now here the first plate, the second plate, the third plate, the fourth plate. Actually I should call them in reverse. This is the first plate, second plate, third plate, fourth plate. The first plate is inserted. On the top of the first plate we place the second plate. On the top of the third plate, second plate we place the third plate, and on the top of it we will be placing the fourth plate. Here the last plate inserted into the cooker is the first plate to take out. So when the idli is cooked, the tray is taken out and the topmost plate is removed first, and then this one. We cannot take the last plate that is available at the bottom at a time. Similarly, the second example is a set of plastic chairs inserted in one in another. That means the set of plastic chairs are available in our home and all these chairs are inserted one into the other. Then operations on a stack. The abstract data type for the stack data structure groups the data items and a set of operations on stack. So abstract data type means the wrapping up of the data members and the set of methods or operations performed on those data members into a single unit. Here the methods means the operations and the data members are the data values that are organized inside the stack. Each of these operations will be securely managed. Will securely manage the data items in the stack. The list of operations are here. There are two portions in the ADT. First one, the data and the top variable, which is used to manage the index. The second one is the list of operations. The push operation, the pop operation, show top item is empty and is full. Push is used to insert an item into the stack, which is passed as parameter. Pop is an operation that will be returning the topmost item as deleted value. Then show will display the data items from top to bottom. Top item is also called the peak operation. This top item will display the topmost item present in the stack. And there are two more functions available called is empty, is full. Is empty is a function that verifies whether the stack is empty or not, and it returns true as an integer value if it is empty. Otherwise, it returns false as 0. Similarly, isFull is a function that will verify whether the stack has no space to insert more data items. That is, whether it is full or not. If it is full, it returns 1. Otherwise, it returns 0.